Topic of the day today is functions, and this would have been all the way back to Unit 1 in our course. So the front page here, there's no real work to check. It's just talking about some of the key vocabulary from way back when. First thing we learned about was a relation, which is literally anything that can be written as a set of ordered pairs. So they gave you some examples over here that are just a listing of ordered pairs, something like the equation there could be graphed as a line, but really basically anything that we've gone over in class has been a relation. Then we talked about domain and range. And remember, domain is, in the big picture, it's our x values, whereas range is the y values. So when we're looking at a set of ordered pairs, you can literally just squiggly brackets and tear the two things apart. But on a graph for domain, we're looking from left to right. So we're scanning across the graph from least to greatest, left to right, looking for x values. And then for the range, we're doing the opposite. We're going from the lowest point to the highest point, looking for y values. And on the graph, we typically use the interval notation, or we write it in words, or sometimes we also saw the inequality option as well. And then the last thing that we looked at was functions, which a function is a special type of relation. It's one where, every member in the x has exactly one value in the y. So in this case, we're looking for things to not be functions that have a repeat in the x or the domains, or something that doesn't pass the vertical line test. Meaning, if we draw any vertical line on the graph, if that vertical line touches the relation more than once, then it's not considered a function. So getting into some actual problems so you can check your work. For the first set here, you're going to see that on this page and the next, these problems are pretty much identical. But for this page, we're just labeling whether they're relations or relations and functions. So for the first four, this is just a search for any repetition in the x's. So right off the bat, I can label that all of these are relations. But the question now becomes, are they special relations, aka functions? So in the first one, the x values are 1, 2, 3, 4, no repeats, so it's a function. Number 2, -4, -1, -4 again, so that's not a function, just a relation. Number 3, this again is called a mapping. The thing to remember is that the arrows work like commas. So this first ordered pair here is the ordered pair 1, 1, and then it's 2, 1. But the problem is that then we get a 2, 2, so that's not going to be a function, just a relation here. And then number 4, if we look scanning the x column, there's no repetition there, so we can actually mark that that is also a function. Now we can get down here to the graph, and again, this is where we're using that vertical line tool. So really what it's saying is if I draw any vertical line across this thing, is it going to cross the relation more than once? And in this case, number 5, both of these would be relations, first of all. But in number 5, the vertical line test is going to pass, so it's a function. Number 6, very clearly, there's several vertical lines that you could draw here. The y-axis is one where it crosses more than once, so it's definitely not a function. Now on page 3, we're looking at those same problems, but this time we're asked to label the domain and range. So for each one of these, we need a D and an R, because we want to be very clear on which one's which, because it does make a difference. And also I can add in the squiggly brackets. And you can see here that with my stylus, they're not coming out very perfect. So just as long as they don't look like a set of parentheses or the square brackets that we'll use for the graphs below. For number 1, domain is literally just listing out the x values. So 1, 2, 3, 4. Don't forget to close your squiggly brackets. For the range values, we're looking at the y's, and it's actually the same set. If by hand you wrote it 2, 3, 4, and the 1, because that's the order that it's presented, I don't think that that would be a problem, but traditionally in a multiple choice, they'll probably have them in numerical order. For number 2, the only difference with this one is we're not going to rewrite that -4 since it's repeated in the x's. So that it will look like there's only 3 x values here, but really we know that there was a 4th ordered pair since the -4 was repeated. For our range, we've got -4 and -6, +4 and -1. For our domain for number 3, we're just looking at what's inside each of the circles. So 1, 2, 3, for our domain, and 1 and 2 for our range. Again, we're not accounting for any repetition there. And for number 4, our domain would be 2, 4, 0, -4. And our range is just that right-hand column. So -9, 2, 5. And then we can actually stop there because that -9 is repeated. Then for our graphs, a couple things we want to keep in mind. First of all, if the relation is cut off by the screen, we want to anticipate that it's going to keep going in that same general direction. So first thing we're going to do here is add arrows. Okay, because a lot of times on a graph, we see that infinity symbol come into play because it goes on forever in certain directions. Again, we'll write DNR for each of these. And again, there's several ways to write domain and range. You've got interval notation, you've got inequalities, or you could just literally say it in words. I'm going to focus on the interval notation that we learned. In this case, our domain, if we scan from left to right, okay, so looking from left to right as we go across, the first thing that I intersect on the graph is this arrow. So that implies that it's going further to the left beyond what I can see, and it's going to keep going until it hits negative infinity. As I scan to the right on the graph, the last thing I see is again the arrow. This time it's going off to the right, so that's a positive infinity. And always parentheses around infinities. Okay, the square brackets are for closed dots and solid lines, whereas the parentheses, if you recall, are for any open dots, or in this case, infinities. Our range is actually going to be identical because the first thing that I see is the arrow on the bottom here, which means it's going down to infinity. And again, the last thing I see is the arrow up at the top, which is pointing upwards, so it's going to go to positive infinity. Number 6, our domain and range are slightly different. The domain, the first thing that I see here is this kind of the end of the C shape, and that happens to cross at the x value -4. So here we're going to use a square bracket at -4, and then the last thing that I see are these 2 arrows, which indicates that it's going forever to the right or to infinity. Now, for the range, the first thing that I encounter as I go up the graph is this bottom arrow. So even though that arrow is heading to the right, it's also going to continue going downward as that parabola extends, so it's going to negative infinity. And as I scan upwards, I follow the C shape, the last thing, the highest point in the graph is the upper arrow, and just like the bottom one, it's going to go, as the graph goes out and to the right, it's going upwards as well, so it's going to go to positive infinity. Now on the last page, I told you when we handed this out that you don't have to worry about function notation, so we're not going to do questions 1 and 2. We are just concerned with the sequence question on the back. So remember, with sequences, you want to find the pattern, and they're going to ask you here for the 8th term, so that's not too far-fetched that we could kind of just count out the next 4 terms and physically write it. If they had asked for something a lot larger than that, instead of just typing in the pattern multiple times in your calculator, what you can do is create an expression to show for any value, typically it's called the nth term, what that term would be from an expression. So the thing we want to find here is that the difference is that each time we're subtracting 7. So again, you can literally just go out the next 4 numbers. And there it is, the 8th term of the sequence would be at -50. If they had wanted an expression, -7 would be our slope times whatever term we're trying to find. And then really what we have to do is we would just want to work backwards and find that starting value. So we're going to add 7 back on to go in reverse. So that would mean +6. And then that would mean if we plugged 8 in here, so instead of doing it the way we just did, we could say that -7 times 8 plus 6, that'd be -56 plus 6. That'd be another way to show that that 8th term is actually -50. So if the problem had been more complex and they wanted to know like the 80th term, then we could plug in 80 for n and get that pretty quickly versus having to count out 80 numbers to get to that point.